Thank you so much for coming on board to the panelists and the attendees today. Today has been a very successful event with about 280 registrations. So we'll see how many attendees there'll be there. Okay, I will be basically starting with my presentation on the Access.space Alliance and also presenting an initial thought on the panelists. And then we'll have 10 minutes presentation from each of the panelists. We'll have also a 15 minutes discussion at the end of the presentations, and then we'll allow about 15 minutes of Q&As from the attendees. So for the attendees, please use the bottom screen where you have Q&A, where you can lodge your question, and then we'll try to read out the questions from the Q&A window there. And if you have any general remarks to the everyone, you can always use the chat window, but just be advised that I won't be actually monitoring the chat window. Okay, thank you. So I'm going to open up my presentation. I'll ask every other panelist to remove the video and also the sound. I'm going to share my screen with my presentation now. Right, so today's webinar is about satellite IoT systems. There's been a great increase in interest of satellite IoT constellations over the past few years. And I thought it was actually a nice thing to do is to make a webinar on this topic. So first of all, I'd like to welcome you to the webinar series of the Access.space Alliance. If you would like to know more about the Access.space Alliance, please go to our website, www.access.space. Later on, I'll show you also a link on YouTube channel where you can also watch all the previous webinars that we have done over the past 10 months since we started on this COVID pandemic, basically. In fact, the webinars were started to support the small satellite sector to continue in their work and also in their PR side and helping everyone during this pandemic period. I mentioned already the agenda. I'm not going to repeat that. So today's webinar is kindly sponsored by Fleet, a company in Australia. Flavia, Tata Nardini is the CEO of Fleet. And thank you very much to Flavia. We'll hear her in a few minutes with her presentation and the business actually she's put together in Australia. And it's a global IoT business, in effect. So a little bit about the Access.space Alliance. Myself, Betty, and Christian are the directors and co-founders. The idea of the Access.space Alliance has come from Betty, who in about 2 or 3 years ago, basically, she thought there was something missing in helping the sector, basically onboarding the sector into the world, basically, especially on the regulatory front. And so we thought of putting together this alliance to help companies to onboard. And especially when you are new, there are many things you need to understand. You need to know about how you actually put together a company and how you move forward, especially on the frequency and regulatory side, of which we are expert of, in effect. The alliance itself is aiming to connect, advise, advocate, promote, research, and also standardize particular technologies, connect, advise, and advocate with the members themselves, and also externally with other stakeholders like governments, for example, and space agencies as well. We also embrace universities and research institutes actually to join us, so that we can actually have also the latest information on technology as well as the business side as well. We formed the company in 2019 as a non-for-profit organization, basically. And the mission is to boost companies, businesses, and technology in many respects. We had a list over the last 2 years, more than 90 organizations joining us. And as I'll explain it in a little while, we have now moved down into a more formal organization. So we were starting the membership from January this year. We started the membership again. These were the companies that were with us up to the end of 2020. And we will have basically a remake of this chart with new companies that will join us from January onwards this year. We have already 3 committees structured in, of course, in a board of the directors. We will have a council which will be made up of companies that will join us as members. And also we will have also committee meetings and committees that will actually review the requirements of the industry. And so far we have a free space optical communications committee, a regulatory and space policy committee, a lunar deployment committee. We had many meetings so far, and of course there'll be new committees be formed very soon. As I said earlier, we started the formalization of the alliance, signing up companies and organizations from this year in January on a fee-paid basis. There are also opportunities for non-fee basis as well. We will be organizing a council. We'll have a first meeting in April this year, and we will be having new committee meetings, starting with finance as well. So on the regulatory side, we have envisaged to have at least 4 regulatory committees this year. On the lunar development side, committee will have one at the end of this month, and there'll be much more going forward. We're organizing already, if you're interested, a lunar development webinar. There'll be 4 starting from the end of February, basically on business, on telecommunications to the moon, and also on other topics which are of interest in deployment, as well as manufacturing on the moon as well. We'll have 4 of those topics coming up this year. Also, we are envisaging topical discussions, roundtable discussions as such. We have already booked 2 dates in March and May. If you're interested, I can provide you more information on that. We're organizing an advice bureau for the members, for those that require advice on anything, from business to legal to regulatory to insurance, for example. We'll have experts into these bureaus that will actually provide the needed advice. And we will be starting to attend meetings internationally. We have an MOU with the CPT, for example, organizing an MOU with the UN Copius, and also conferences, international space conferences as well. We'll be starting to do that. And a conference is coming up. We are organizing one for the middle of April as well. I'm going to provide you the slides so you can actually look at the link that we have here, and you can actually watch the previous webinars, including this one, once actually it's been formatted and uploaded into YouTube channel. Today's webinar, as of this morning, we have about 270 registered individuals. As you can see, many are from the UK, many also from Europe. I have a chart separately next page. And of course, so we are about 54 different countries represented today who have been registered. And the distribution of those participants and from which country they are also on the chart on the right side. As well as on this chart is the type of companies that actually are registered. You see there's many companies with 1 to 20 employees, and pretty much constant between 20 employees to about 5,000 employees, about 20 registered individuals from those companies, and a bit less, of course, of the bigger companies. In terms of geographical distribution, you see here a pie chart. Most are from Europe, but of course, we have many in MENA, Asia, Americas, and Africa as well. So today's webinar, we have 4 exceptional individuals from UK, as well as from Spain and Australia, and Italy, of course, as well. We thought actually of making this webinar today Italian only because we have the majority of Italian panelists today. So if you don't mind, we're going to now switch to Italian, okay? All right, so we're going to move on, and we're going to start with Flavia next to make her presentation. Flavia, if you're ready, please take the screen. Welcome.
Hi, everyone, and I'll switch to English again, I guess. A pleasure to be invited to this one, calling from beautiful Australia. It's 11 p.m. here, so, you know, I'm trying to keep awake, but, you know, I'm looking forward to share this story with you. So let me share my screen. Okay, so I'm here to talk to you about a little bit about IoT, about Fleet. I'm the CEO and co-founder. Fleet was co-founded 5.5 years ago. It is an Australian-based company with offices in Europe and US. Something that we are very proud of and I want to talk to you about today is why we exist and why IoT is important. When I started Fleet, for me was a big understanding that it's a big revolution that is happening in industries. It's really, you know, they call it the fourth industrial revolution, and IoT is underpinning this change. So for a founder, it was kind of an enjoyable moment to build a startup in the middle of such a big revolution. What is happening in industry that really triggered this IoT revolution is the digitalization. So there are a lot of industries in which particularly the one in remote areas and big assets, they're kind of moving to digitalize more data from their infrastructure. And that creates a lot of fears and a lot of obstacles. So when we build Fleet, we want to try to overcome those. I'm a big believer that every big change in humankind starts with connectivity, particularly when it comes to industries. Like connectivity changed forever the way we use our iPhones, computers. And this new revolution is really underpinned by a different type of connectivity that really helps industry to go to the next level of understanding of their assets and digitalization. Why satellites in this thing? Because everyone knows that the IoT revolution is hitting our world. Satellites, of course, play an important role when we're talking about industry and remote access, because the terrestrial infrastructure cover really like 3% of our planet, and the rest, including oceans, is very unconnected. So there is a kind of a block to not allow this IoT revolution to happen. And of course, as we know, space is changing, and thanks for beautiful, crazy software billionaires that created companies that are bringing us to space every second day, we are having an ability to build satellites that are much smaller. So the reason, for example, why we choose small satellites at Fleet, we use a 6-unit platform, is because it's absolutely perfect for low Earth orbit and industrial IoT. IoT is small bandwidth, small power. It's not like the big platform, so it's such an interesting candidate for IoT. One thing that at Fleet we are really, really passionate about is all these new wireless technology that are transforming industry. And you will hear this also from Lacuna as well. LoRa and low power wide area networks are protocols that are changing the world, in your house, with your Alexa or your Google Home, or in industries. These are protocols similar to the GSM protocols that are absolutely changing the way we connect assets and sensors around the world. What I found very fascinating that in space world, we always think that satellites are actually better than terrestrial infrastructure. It's actually really hard because terrestrial infrastructure actually, they go really fast and they're easier to deploy. So at Fleet, we wanted to leverage this type of technologies and make them available around Earth. So we have 3 main important pillars of Fleet. One is the infrastructure in the sky. There is a constellation of small satellites. One is a gateway on the ground that aggregates data, improves security and efficiency. And we leverage this massive ecosystem of low power wireless sensors that enables fantastic applications. So we created this with 2 amazing patents, really, to technology that Fleet leverage. One is on the small satellites. What actually Fleet is doing, I believe is the most powerful beamforming system on a 6-unit. So it's all digital and it allows a massive throughput. So each of our satellites have got a capacity of way bigger satellites. But also we create something really special for satellite connectivity that is a network edge system. So satellites has always been, I gather all this data and I send all this data and I just spend a lot of money to move data. We have kind of changed this approach and brought a lot of network management system and software so that data get analyzed in the field, and there is a reduction in data that gets sent, just the smart data gets sent through the network. So Fleet network enables connectivity to hundreds of millions of devices, if not more. So it's a massive scale. So we say always that it is very high capacity and it's built for massive scale. So not on a handful of sensors on the ground, but millions. So we have built these amazing payloads, and I'm so proud of my team. And my team is now around 50 people. And we launched 4 satellites in 2018. Now we are launching 3, and we're going to mass production next year. And this 7 satellites journey was just to build this digital payload that is absolutely amazing. And I don't even know how we managed to get there. It was a very specific vision on enabling small satellites to have maximum capacity. Our network is 140 satellites in low Earth orbit. It is a big network. It's got edge computing in the network. So it kind of enables amazing efficiency and incredible latency. Fleet with 4 satellites, we can provide an incredible latency, because it's not just about action that are decided by the satellites, but action decided on the ground. We launched 4 satellites. We brought into use S-band frequency around the world. So we kind of work with a bit away from UHF with a little bit more frequency available. The portal is our flagship product, and it's not just like everyone use a simple gateway. It's very complicated box. It has machine learning, edge computing, can connect thousands of hundreds of sensors. So this is a very specific edge server that maximizes security. And then Fleet has built a pretty incredible mission control system called Nebula. And one of the most complicated things about managing a network global on IoT is remote manage it. It's all software based. This is the shift in paradigm in space. It's not hardware anymore that is important, it's the software stack. And the first 5 years, we have put so many things in the field and learned that remote management, IoT deployment in way that include AI and machine learning is the key. And it's very complex. And it needs satellites, and it needs a lot of interesting AI and machine learning everywhere in the stack. For the last minute, I want to tell you there's something that is really important at Fleet. The Fleet, because of this high-level security stack, this very complex remote management, all this network management of the sensors that is not in the cloud, but in the edge, in the field, and in the satellites, we have built this complex system for critical infrastructure. So Fleet is laser focused, dedicated to critical infrastructure. So we work very much in energy, so on transmission and distribution networks around the world. And it's all about connecting this asset that usually got zero visibility with amazing sensors on poles and wires to minimize outages, events around the world. And this is because the energy networks are kind of changing around the world. It is all driven by Elon Musk and Tesla and the EV that are bringing power in the network. The network need to be visible, and they are so extensive. And most of the networks connectivity is not available. So we have built an application end-to-end for this. We have built an end-to-end application for monitoring of pipelines for gas and water, in which we can, with machine learning and cameras and edge computing, detect threats. And this is a very big topic because in US, people die every month for gas explosion, and we don't really like it. Then mining production and water operation is big for us. So we work with very high level critical infrastructure industrial deployments. And hydro, I wrote here, water is critical to mankind, because it is. And we have learned in the past years working with this massive industrial deployment that we can do a lot by monitoring them from space. If everyone wants to contact me and talk about it, this is my email address. But 10 minutes are not enough to tell you about an amazing journey. But I want to take 3 seconds to tell you that Fleet also launched a moon mission this year, because with our customers, we solve such an end-to-end application on resources, exploration, finding water, understanding subsurface, that all our customers and us created a moon mission called the Seven Sisters. And we're going to use the same IoT technologies on the moon. So that's Fleet.
Thank you, Flavia. There was a question about latency. Can you just maybe tell us the latency?
So what is the latency? So Fleet, the latency works this way. So because Fleet has got an edge computing system, most of the sensors get actions by the edge computing. So with 4 satellites, I look at latency like this. In the industry, there are 4 levels of interest about latency, particularly the industry that we look at. Best is 5 minutes, then 10 minutes, 30 minutes, and 4 hours. You can, on all the application that I've talked about, share it like that. You also, so our edge computing with in-local reaction act to everything that need latency less than 5 minutes. With my 4 satellites, I have, depending, 3 to 4 hours. Fleet uses other satellites as well, so we will have a very complex system. That portal has got 4G, NB-IoT, LoRa, is connected to our 2 satellite constellation. So my customers, if there is a threat that they need to solve by getting that into the cloud instead of acting on edge, they've got the data in a second. So while we build our big constellation, we got support of premium services on other satellite constellation. So we actually built a product that can serve critical infrastructure quite nicely. And we're very lucky with that because latency is a problem.
Thank you, Flavia. I think we have to move now to Armando. Thank you very much.
Thanks.
Armando?
Hello, let me just share my screen. Can everyone see the presentation?
Yes.
Okay. So firstly, thank you, Tony, for inviting Nano Avionics to speak in this panel. My name is Armando. I'm the lead business development manager at Nano Avionics UK. And I'm going to talk to you a little bit about the company and what we do to enable those customers that are looking to build IoT constellations and our approach to the IoT space. About Nano Avionics. Nano Avionics is a company that was founded in 2014 as a spin-off of Vilnius University. We are an end-to-end mission integrator, and we are a new space prime providing wide applicability end-to-end space infrastructure. Our mission is to enable a wide range of satellite-based businesses and organizations to globally provide affordable and timely access to space. We provide end-to-end solutions regarding satellite buses, hardware and software, launch integration, and operations. Our story started, as I said, in Vilnius in 2014 as a spin-off of a university project. Our founders grew the company around a cluster where we were able to set up a supply chain that helped us quite a bit from a technological standpoint. We grew to about 50 people. Then we got a little bit of investment from the US that enabled us to expand our offices to Midland, Texas, and Columbia, Illinois, where we have a team for our US-based customers. Very recently, last November, we opened offices in the UK to build in a similar philosophy as with Lithuania, a technology cluster around the company to be able to serve the constellation market in the UK. The company currently has about 100 people around the world. Most of the team is based in Lithuania currently, but we're looking to grow it. And our whole idea is to provide local integration and production capabilities in all of the regions to enable global operations and have that infrastructure to serve our customers. We've got experience in 90+ missions. Most recently, we had the R2 mission that launched about 3 months ago, more or less. And also the Aerovista mission is one that we've got planned for 2 satellites. And we launched a mission with Aurora Insight quite recently, a couple of weeks back. So we've got a lot of flight heritage, and we fly regular missions for our customers. We've delivered products and services to pretty much everywhere in the world. We operate in Asia, Middle East, Europe, North and South America, and Australia. We work commercially with new space startups and with older space incumbents, with commercial companies, research institutes, universities, and governments. And in general, we cover the business applications field, in general IoT, which is the prime conversation today, communications, applied and industrial research, and fundamental research. However, we are neutral We are a neutral support provider. We aim to work with anybody and everybody that needs the infrastructure to operate. We don't engage directly in providing IoT services. So our whole business model is verticalized. We touch the space segment, the launch segment, and the satellite operations. We build our buses in such a way where it's easy for our customers to integrate the payloads. I'll go into it a little bit later. And we also ensure that our customers are able to access launch brokerage services quite easily, and we help with the integration when needed. When it comes to satellite operations, we can help with frequency registration and the commissioning of the satellites, as well as mission operations themselves. Whether the customer wants to do the operations themselves or have us do it, we try to provide as much support as possible. So what's interesting about Nano Avionics is that we designed our buses to be able to be standardized. So we've come up with a design that's pre-configured, which means that anybody can plug in any type of payload. This is particularly interesting in the IoT space because when you need a lot of satellites to cover a large base of the Earth, as Flavia pointed out, you need to be able to keep the cost down. And that's one of the key drivers that we've identified in this space. We provide mission integration services where we are fast to market, cheap to manufacture, and very, very, very reliable. In general, most of our satellites can serve relatively high performance solutions, and all of our satellites have flight heritage in our components and in general as a system. With satellite operations, we've got an operations center. We're actually building a constellation operations center in the UK as well as what we already have in Lithuania. We have a mission control software that is quite robust, enables us to operate satellites very, very easily and efficiently for our customers. And we have a myriad of partners for the ground segment where we can adapt to whatever ground station the customer wants to use, as well as whatever kind of backend the customer is looking at using. So Nano Avionics is one of the key enablers in getting this IoT infrastructure to market. In general, and this is probably going to be a common thread with all of the presentations, we've only got 25% to 30% of the world's landmass served by cellular network infrastructure. Satellites enable you to cover the rest, all those dead zones that we have, not only in the oceans, but say, if anybody's driven through France, you know that there's quite a lot of roads that you just don't have any service at. So stuff like that, this enables companies that are dealing with, for example, logistics, to be able to not only track their lorries, but also make sure that, for example, temperature of food in those lorries is kept at stable levels, or if there's any problem in shipping lanes, you get to know where and what is happening on time and reliably. Now, Nano Avionics has gone a slightly different route to the rest of the players in this panel. We've gone the constellation as a service route with our GIoT project. Our philosophy is to enable any IoT providers to be able to put their payloads on our satellites and then create a constellation whereby that data can be transferred easily and as many players as possible can connect to that constellation so that the existing infrastructure is there and it's easier to put an IoT service online. Our reliable flight-proven environment is not only, very secure. We also try to be able to provide 100% duty cycle to those payloads, which is quite important for IoT. And in general, that's the mission. We're neutral and we provide the infrastructure. So what are the kind of applications? I've touched a little bit on this already, but you can look at monitoring infrastructure. So again, Flavia pointed it out, and we're going to get a lot of the same messages here, but gas and oil pipelines, power grids, civil infrastructure. There's examples where cities are starting to monitor some of the traffic lights with IoT networks. You can also monitor a lot of the agri-tech sector is moving towards monitoring humidities, temperatures, soil with IoT devices, which enables much more efficient growth of crops, which is going to be a problem in and of itself over the coming years with overpopulation. You can also monitor how much pollution you have in a city, light pollution, CO2, water levels, and so on and so forth. We are also looking at the tracking of objects, fleet management and cargo tracking. So ADS-B payloads, tracking of, as I said, lorries, and then also emergency communications. So somebody sends a specific signal to be able to be tracked. That is enabled by our satellites. So we've collaborated with some players. Obviously, Lacuna generously tweeted when we launched one of their satellites last year. We've already launched 3 satellites with Lacuna, and they're operating. I guess Rob can probably go more in depth as to what Lacuna is doing with those satellites. So that's Nano Avionics in a nutshell. And I thank you for the presentation. If there's any questions that we can answer now, we can go ahead and answer them.
I'm going to move on to the presentation. If there are some questions on the Q&A on the Q&A window, just answer them directly, and then we'll have more questions at the end. Okay.
Sounds good.
So thank you so much, Armando. I would like to get Rob now, please.
Hey everybody, can you hear me okay, Tony?
Yep, that's good, thanks.
Great, right, just going to share the screen. Okay, so yeah, firstly, thanks very much for the opportunity to present here. Obviously, it's yeah, really exciting sort of area to be working in just at the moment. Pleased that you've kind of constructed this webinar. I was just going to take a step back when I started before I sort of go into sort of what Lacuna is and what it does, and just look at it, the whole IoT market and satellites. You know, I think as Flavia correctly says, it's, you know, this is a huge revolution that's going on, but in part of this revolution, satellite IoT isn't new. I mean, it's been around a long time, but it hasn't really gained the absolute mass adoption and delivered on the benefits of space that we expected. You know, and I think that's partly because we just, as an industry, we just think of satcoms traditionally as a premium service. It's the thing that you use where no other option exists. And the issue, as far as IoT is concerned, is the actual data is such small packets of data that trying to make business cases around a premium service is just really tough. It's one thing if you're connecting a phone, which has got maybe, you know, megabytes of data, but trying to connect a thermometer that's got like bytes of data per year, it's really tough to try and make a business out of that through satellites. And it must be said as well, even for terrestrial IoT, this is clearly going to happen, but the time of it all happening is the thing that's a challenge to everybody in the industry, whether it be the terrestrial side or the satellite side. I think, as we've already said before, you know, the key thing that's changed everything is local satellites and small satellites. You know, we find even the much larger players now are sort of moving towards, you know, sort of smaller satellites, recognizing that there's a benefit and a role for those. And there's a whole plethora of IoT satellite startup companies all based around small satellites. These are a couple of Lacuna's satellites that are provided for us in these 2 instances by Nano Avionics. And the issue for us, I think, is that, you know, and this is an issue for the whole industry, is the satellites are just a small part of the story. The biggest part of the story is how you're going to connect it and what the user experience is on the ground, and how well that they're going to be able to tap into this technology and do it cheaply and easily. So for us, our whole proposition is based around this particular one of the low power wide area networks called LoRa and LoRaWAN. There are at the moment around the world in major cities and places already LoRa networks. These are networks that transfer very small packets of data at very low powers. Those are there, they exist, it's gaining a lot of traction year on year. The amount of connections are doubling that are using this protocol. However, for us, what our story was about is how do we extend that connectivity to remote areas using satellites? How do we plug that into existing systems so that it is seamless to user? It just looks like it's as simple as plugging in a normal LoRa device as far as possible. We think this is really important because the reason that Wi-Fi got the traction it did was because it was a standard and a mass standard that everybody could coalesce behind. And at the moment, LoRa is one of the low power wide area network that's getting by far the most traction. So for us, it's all about LoRa. And for us, in that story of making it as simple as possible, these are devices. And this, what you're looking at here, is not only a sensor, but it's also the satellite gateway. It's really simple, really very, very simple. So this particular device here has got number of sensors in it: temperature, pressure, humidity, accelerometers, motion sensors. And what you see on the top there is the antenna that connects direct to the satellite. So it is the sensor and the gateway all in one thing, all in your hand, and off a single battery charge will last for many, many years. So what it's all about for us is trying to make sure that you could take an existing LoRa device and with the minimum of it changes, because these LoRa devices are available off the shelf, you could connect it to the satellite. A couple of changes you're going to need. You're going to need a slightly different antenna that you can see there on the left-hand side. You're going to need slightly different software, and that software we're going to open source. It'll be freely available to put on existing off-the-shelf devices. And even if that's too much of a challenge, you can use these devices as a relay. So you can actually take an existing off-the-shelf LoRa device. I've got an example here of a temperature sensor in a freezer. It's connected to one of our nodes on the roof of a building. It can then just relay it simply. And this is all straightforward, very low cost stuff. So quick couple of words about satellites and the frequencies. To this sort of audience, I don't need to explain it in great detail, but it's essentially largely polar orbiting satellites around 500 kilometers, with the odd infill satellite, which is at a lower inclination, so it fills in and improves the latency of the equatorial regions. We get our satellites from a number of people, including Nano Avionics, as you heard so far. Likewise, for the ground stations, we use a number of systems, including Leaf as well. So you'll get to hear about that, I guess, in the next slide. The key bit of the IP is the receiver, the really sensitive receiver that enables us to receive these signals direct from normal LoRa devices published at the level that you'd normally see for terrestrial LoRa, and to detect those in space. That payload that can do that is our key intellectual property. That's what we protect, that's what we build ourselves, and that's where the key challenge is as far as we're concerned. A couple of quick sort of shots on typical types of applications. So we're working with a company Miramiko, who are building the connectivity into cargo trackers. They're also building it into soil moisture sensors. Smart agriculture is a really big potential. You don't need to go very far on farms before you run out of connectivity. So being able to build this connectivity straight into off-the-shelf soil moisture sensors is very valuable. I thought I'd put in a few fun things as well. Here's a project where we're tracking elephants in a national park in Kenya. So if you ever wondered what a collar looked like where you put a device on an elephant, that's what it looks like on the right-hand side. Quite a surprise to me when I saw it the first time. This is another one that I think is interesting because it builds on all the smart and the edge computing that Flavia mentioned. With this one, we got a project that was essentially sending photographs back over satellite, where it's measuring the activity of a penguin colony and seeing how many there were in the place at a particular time. So instead of actually sending a photograph back, the machine learning was put into the device on the end so that it could detect and measure how many penguins there were in the view. Then that got translated into a very small IoT packet that was easy to send back with our connectivity that got built into the device. One final one, this is a couple of Danish architects from a company called Saga Space Architects. They're designing sort of habitats for deployment on the moon, and they've just, a couple of guys from there have just spent last 3 months in Greenland, and our connectivity is on the top of this little habitat so that they can send messages back. And given they're Danish, they had to get a Lego angle into it, so we've got a small rover hacking about with our little device on the top as well in Greenland at the moment. I guess just a couple more slides. So if you want to join in and want to help us build out the ecosystem, we've got a technology partnership program where lots of device manufacturers are putting our connectivity into their devices so that you can then buy them off the shelf. We've also got an evaluation service where for system integrators and bigger users, we're giving priority access to the system so that they can build out their solutions to provide to different people. We should have dev kit. The dev kits will be available in the summer, and then we'll be opening it up for general commercial service from September of this year. Quick couple of words about final constellation. Constellation we've done filed 240 satellites. That'll enable us to get down to the sort of 5 to 10 minutes sort of latency, possibly better, obviously depending on your latitude. In anticipation of the current, the question about latency of the current system, we've currently got 4 payloads in orbit. We'll have 12 more at the end of the year. So currently, depending on latitude, it can be, in the absolute worst case, sort of 12-hour service, sometimes 6 hours. Obviously, as you go up in latitude, you get much more coverage. So typically sort of 6 hours or better over Europe, as an example. So if you've got any questions, here's the, or want to contact us, here's the links in the presentation that I think Tony will be circulating.
Thank you, Rob. We'll get the question and answer at the end. So please keep on writing your questions on the window. Rob or others can also answer them live, but the ones that remain, we'll ask them at the end. So the last speaker, Giovanni, you're on now. Thank you.
Thank you, guys, and thank you, Tony, for inviting me at this presentation. I'm really glad to be here with a lot of partners presenting. So I believe it even makes much more sense to talk about IoT and how we support the IoT sector with our ground segment as a service. So LeafSpace is a ground segment as a service provider. We founded the company back in 2014 and actually commercially operative with a service from end of 2017, start of 2018. And the IoT has been one of our first markets that we gathered to. And why? Because we listen a lot with Flavia, Nano Avionics, and Lacuna about the need for low latency, and not only low latency on the single satellites, but of course also optimized to different kind of orbits or different number of satellites. And also, a way to have a linear approach to ground segments. So try to really, for our customers, to outsource everything that is not core as the ground segment. And then, of course, reduce the startup time and effort to get on the mission operation as soon as possible. And then, of course, be cost effectiveness, because every euro that we put on a pass is a euro that our customer need to put on every megabyte or kilobyte that has been transmitted through their network. So for these and other markets that we're following, like Earth observations, etc., we came out with different ground segment as a service solutions, of which the most big one right now is Leafline, that is a fully managed multi-mission shared ground station network that is particularly good for small constellations or single satellite missions where you need to have a high capacity network with different locations around the world, but you just want, of course, to pay for what you use. Instead, if you're growing for a constellation, maybe the multi-mission shared scheme doesn't work anymore economically. And so for that, we have LeafKey, that is a dedicated ground segment as a service. So basically, we build up networks just for single missions or single constellations. So we can both optimize the ground station itself, but also the software infrastructure and the deployment plan of our ground station to provide the right capacity at the right time, at the right price to our customers. Last year, we also adopted this ground segment as a service concept to another product that is not really related to IoT, but in some way it is related because we provide telemetry service to launch vehicles, and we have this service called LVT, and we started to provide it with Virgin Orbit, and now we are expanding also to other providers, so we can basically track all the stages from the launch vehicles to the satellite deployment and lead up to the actual operation of the single satellite missions and constellations. And all these services are have these common added values. So we have global coverage, we have a really easy and fast onboarding in our systems and APIs and interfaces. They are all services that are fully managed, so we take care of everything from the maintenance of the ground station to the deployment to the to the operation and day-to-day operation, etc. of our network. So the customer doesn't have to worry about anything on our side. Of course, we are flexible and scalable. We base all our orchestration management software in the cloud, so we can scale really, really fast and also balance the load from one station to the other and always increase the number of stations that we have. And one particular thing that is quite unique in this market is that we have optimized scheduling. So we take all the possible passes that we can have all our network, and we optimize it to provide a really effective service to our customer, but also having an efficient way to operate our network. These are the stations that we have right now. The one is in blue. You see that we are quite well covered in Europe, and we have also activated a new station in New Zealand in December last year. We're going to go quite a heavy deployment plan this year, thanks also to the closing of our Series A funding. So we will cover Australia, Sri Lanka, that will give us access to the equatorial orbit, and then also North America, Iceland, and Africa. In this way, we can cover basically all kind of orbits with one or more passes per orbit. And this is really, really good for latency, as we will see later. And then, of course, we plan to expand even more depending on customer demand in the coming years. So about Leafline, it's really, really easy, as I said, to integrate and onboarding. So we just need your spacecraft details. We set up your account and the ground station network, including the licensing. This is quite an important point that we do in order to be fully legal and fully operative in all our countries where we operate. And then we set the automatic scheduling through our API for your mission, and then you just start operating. Depending on the mission, we have been quite really, really fast. We have done also some missions we enable some mission in a matter of days, and with different stations around the world. So this is really one of our major points. This is just to give you an idea of what we do as a fully managed service. So we basically act as a data pipeline. So on your side as satellite operator, you don't need to connect to every single station, but we route the data from one station that is in touch with your satellite to your mission control software or mission control center in a seamless way. We really reduced latency. So we cover, we have, I believe the highest latency that we have right now is between here in Europe and New Zealand, where we have 350 milliseconds of latency from ground station to the mission control software. And we take away everything. Also, the architecture that we have enabled is based on providing an end-to-end cybersecurity. So all the data that pass through are directly encrypted by the customer, and there is no any key distribution management with us. So we can be really, really safe on that. Just to give you an idea of we have done an IoT case study, because as you've seen, we have quite a lot of partners operating this in this market, and just wanted to give you also, a short brief. So if we take the case of a 12 satellites constellation USSO orbits using Leafline optimized with latency in mind, this is the kind of latency distribution. For latency here, I mean the time that pass from one pass to the other. So basically, the maximum time that you can have from once the data is gathered and when it's downlinked to the next station. As you see, with the kind of deployment plan that we have for this year, we can get to really low latency and providing around 40 hours per day of contact time to the entire constellation. That means 26 contacts per day per satellite. And if you also use inter-satellite link, a long plane, you can really reduce the overall latency and have basically 85% of the time that you're under 5 minutes of latency, really enabling quite a lot of application, not just of data of remote monitoring, but also remote controlling. And then one thing that is good for the lift lines, that the price to operate this station could be around 1.5, 1.7 million euros per year, and this is with lift line. Once you go up with a number of satellites and the constellation itself, you can pass through to a lift key that is much more economical, efficient, of course, when you have the numbers to sustain that. And one last thing is for a demo, but this is one of our ground stations. This is the station in Italy actually performing a pass with an IoT satellite. And well, I can just say that this is a satellite with some of the partners here in the panel, and it's easy, like it's simple. So we start the pass automatically. We have on-call operators, of course, replying to any kind of need from our customers and always monitoring the network. But then all the data that you see now that are downlinked from satellite directly transmitted to the customer in a seamless way. And that's it. So of course, if you have any question, just ask, and here you can find also my contacts, and happy to answer to any of your questions later.
Thank you, Giovanni. There will be questions after the panel discussion. So please put your questions on the Q&A box. If you want to answer some questions already, you can do that live as well. So let me have all the panelists actually on video now, and so we have a short discussion on for the next 10 minutes, 10-15 minutes. So thank you so much for your presentation. They're actually really interesting to listen to your presentations and see the progress of the IoT satellite systems. It's basically a data network as such, for low-speed data network in effect, with some other integrations as well. So I have I would like to maybe initiate a couple of questions for discussion to the panel, which I thought about. One is the economic sustainability, for example, of an IoT satellite constellation, basically, and basically comparing a constellation of your own where you actually you build, you develop, you build, and then you launch, and then you operate the satellites and so on. With respect, instead, if you were piggybacking payloads in existing constellations, basically, whenever, of course, they launch, in effect. So. What is your view on that? Maybe each one of you, if you can have maybe a reply to this. What is more cost effective on your side, you think?
I'm happy to go first if you want. Yeah, I think the answer is it depends. It really, there are so many different configurations. Each of us as IoT companies have got very different solutions that we're offering, and the biggest problem is just the expression IoT. There's such a vast range of things that are encompassed in that description. Each of us has got a system that's optimized to suit a particular niche within that huge paradigm. And then depending which niche you're doing, it drives sort of what your solution is. So, a conversation that turns around and says, is Fleet better than Lacuna or better than another thing is kind of just completely miss the point. There are situations where what we do will work fabulously well, and there'll be situations where Fleet is a better solution. And so in that same way, the way that you actually address the market kind of is driven by that. So for Lacuna, for example, we're working with very low power signals arriving at satellite. For us, actually putting that, hosting that on larger payloads brings an awful lot of sort of integration risks because of the noise and the noise background, whereas I'm sure the trades are very different for Flavia.
Anybody else? Flavia, on your side, what do you think about the economic sustainability?
I mean, I think the key here is about data, and data is what we are moving, and data what we are providing. And we, if we need to provide a lot of data, every sensible CEO, co-founder will just find the cheapest way and most scalable way to do it. Now, when you have to deploy a constellation satellite, you need to have speed. You need to have speed. You need to vertically integrate. There's a lot that you have to do to make it to a gross profit and gross margin. Okay, we are talking about, you know, big revenues even to sustain a constellation satellites. When it goes to kind of payloads on other constellation, I think it depends on the constellation, you know, because some of them they go very slow, so it actually slows you down. For me, it's all about speed. Like if I can count on someone, I'll probably count on Elon. You're gonna put more payloads of me in space, go for it. Like what I want to achieve is not, you know, I strongly believe the nano satellites will change the way we approach Mars and Moon. This is why Fleet is very, very focused on developing our own small satellites. They're going to be platforms that are going to completely change the way Moon and Mars comms works. But my goal is that if there is a more beneficial way to deploy stuff, the problem that I've got, you know, I understand, Rob, interference and low bandwidth. Fleet does a lot of complicated edge computing and pretty complex stuff with the satellites. So my satellites are pretty unique, and I really struggle, you know, even when I use other constellation satellites, I don't have the same things that I need. So this is why. But, you know, no one loves to raise 100 million to build a constellation satellite, you know. The lower the cost is, the better it is.
I think that gives a perfect illustration of the trades, doesn't it? So for Lacuna, the difference for us is that we're not so worried about the selection of satellite. It's not so special or different to us. So once again, different solutions, different trades, different answers.
Yeah, I can understand also the fact that constellations, once you launch a Iridium constellation, then you have to wait another 20 years or another 15 years maybe to launch another one. Or whenever you launch maybe SpaceX, okay, after an initial deployment, then you have to wait a few years before you can start launching. And then also you're actually adopting your needs to that particular satellite system that you're constructing yourself, actually. As you say, Flavia, in effect. The other thing is that another question I was posed by a colleague last week was there is a limited amount of spectrum and bands below 1 gigahertz, and there is also some spectrum availability, although it's actually shared with other satellite missions, basically space missions, above 1 gigahertz. You know, there's a lot of every single month or every single week, you always hear out of a new constellation coming. How many constellations of IoT systems can you actually have and fit? Will the market decide, or is it, or do you believe actually it's open-ended?
Rob, if you want to go, and then I go.
Yeah, I mean, to me it feels. I mean, clearly the amount of systems that you know, the amount of companies out there doing it at the moment is there's going to be a big shakedown. Not all of those can be successful, even in the sort of wildest dreams and ambitions of IoT. There will be a shakedown, and of course, that's always the market is the thing that determines that. It feels. I mean, when I started, I thought that we started out on this 3.5 years ago, and it just horrifies me. Every 3 months there's like a new concept and a new person coming in, and it's just surprising. There will be a shakedown. It feels very much like AIS felt sort of probably a decade or so ago, when everybody seemed to be rushing to get those services. And I'm sure that it will follow the pattern that things went with AIS. A lot of people fell by the way, but there will be, I do believe there's room for several survivors, and those survivors will each be optimized for a slightly different niche within that overall IoT sphere. But as to which ones the survivors will be, well, that's what makes life interesting.
I don't know if anybody else would like to take this as well. I don't know, Armando, I haven't heard from you, and Giovanni as well.
Well, I think that the frequency spectrum part is important. There's a number of things that can be done from the ITU side and in terms of narrowband spectrum techniques that we can kind of work through. But I think everybody's missing a big problem there, and it's the hardware problem. When you have constellations that are in the thousands and tens of thousands, there's the problem of collisions. So there's also an element of actual space that you have there. And I think that there's probably going to be a shift to how the ITU manages geo orbits. There's going to have to be some sort of registry as to who uses what orbit and how, other than just tracking. And there's probably going to be some fights as to who gets what orbit in the future.
Well, there is a WRC-23, which is going to look at new frequency bands, but you're raising another good point, Armando. It's about whoever comes first, for example, in occupying a particular orbit shell, and then somebody else wants to do the same orbital shell, basically. Who's going to be able to manage that, and how you're going to manage the potential orbital collisions, especially if some of these satellites don't have maneuvering. In fact, I could pose another question to everyone here. How are you managing your orbital maneuvering at all, or if at all you're managing it, and how you managing orbital debris after the lifetime of the satellites? Is there a particular formula that you are adopting? I don't know, Flavia, Rob, and Armando, Giovanni, if you know anything.
I mean, nanosatellites per se, they decay. So it's very, very important actually to put in an altitude in which at the end of the lifetime they come down, and that's it. Now, propulsion system versus not propulsion system. I think someone asked that question. I mean, we have seen planets operating 330 satellites with a propulsion system, and they've got no intention to put a propulsion system. Why? Because that's the nature of this constellation of satellites. Sometimes one goes down, and the failure rate is 70%. You keep launching them. It's terrible, but it is what it is. And I agree, Armando, there is not much space, but there's a lot of space. As long as we are regulated and we do stuff, I receive calls every day, like every second day, that there is something 250 kilometers from Centauri 1, or one day was 3 meters, and I'm like, 3 meters is actually pretty close. And what do you do? I think what is very important and people underestimate is that when you have a constellation of satellites, you need to put the satellites in the right orbit, because you have a filing. You have a filing and you need to follow the rules. So the problem is not really do you use a propulsion system to extend the lifetime or to maneuver it. We are not talking about geosatellites per se. The key is that can you reach the orbit you want? So a lot of people actually talk not about the real problem. The real problem of constellation is how do you reach the orbit you want? Because when you want to deploy 100 things in 20 orbit planes, following the ITU regulations, and you need to launch piggyback with SpaceX, you're not going to go where you want to go. So that's where propulsion system really come in handy from my point of view.
Okay.
I wanted to add also to what Flavia said, that this so we are also seeing a lot of let me say kind of conflicts between nanosatellite operators and of course the huge deployment of Starlink in these years, or that of course also lowered the orbit, etc. So this of course it's even a point that where we need to have more and more close collaboration with the different operators, but not just only that, but we need to have a regulatory framework that works on that side. And I believe also one of the functions of access.space is really to talk about this, because otherwise we will have different strategies to get into orbit, much less number of strategies to get out of orbit, and we need to, and also from the satellite operators need to think about the collision avoidance as one part and one real part of the operations of their constellation. And on our side, of course, we're trying to work on that side, providing more and more access to those satellites in a seamless way. But definitely, once you have a collision and you need to move the satellite or to do some kind of differential drag maneuver, you need to know how to do it and know also how fast you can do it, because this is just a matter of control of the spacecraft and operation. And it's not just regulatory, it's really to think about our constellation overall, not just as a bunch of satellites, but as a single system that you need to control and to manage.
It seems to me that the solution of launching so many satellites in space and leave them there, and then hopefully at the end of lifetime they will come down, you are actually pushing towards a solution that to use the sort of lower orbital shells, 300, 400 kilometers, rather than actually going up to 700, 800, 900, which actually you need actually much more. They will actually stay a much more longer time in orbit actually if you don't have any maneuvering. So it seems that the solution for IoT satellite systems or satellite systems that have this kind of technology are actually apt for lower orbits rather than the higher orbits. So that's sort of the
choose the right altitude.
Yeah. Yes, I have actually a question from the attendees. Actually, somebody asked me the following. You can read it actually on the screen. I'm going to read it out. We are seeing two kinds of satellite IoT approaches here: Fleet with gateway and Lacuna with low power direct to satellite. Can you discuss with the panelists what use case is good for one and for the other, and also the pros and the cons?
Well, I've got a very strong opinion, so I'm gonna go. And Rob, I love you. Okay, so you have to bear in mind that with our satellites we can do both. Okay, I mean our satellites are pretty capable, and our technologies allows us to do both. And in the past 5 years, I've invested. We have, Fleet this year managed to reach companies like PHP. So we are in a year in which we really smashed it in sales, and it took a long time. Like, in the first 3 years, it was all investigating of what is what. In my opinion, and what I've learned about comms and IoT, that connectivity is a commodity. It is a commodity, So just funneling and backhauling data is a pure commodity and don't add any extra value to the customer experience. Is not sticky in the customer's life, and the application are much less. So when you actually bring a layer of computing and edge and security and aggregating data and analyzing data, do machine learning, that is where the value comes in. So massive IoT deployment is what I call when you aggregate and you have the ability to do analysis of data and machine learning in the field. And you kind of bring that extra layer. I mean, if you look at Fleet is not a low-cost provider. Fleet is in a really bizarre way, is a premium provider, because we provide layer of stacks that goes way behind connectivity. So in my experience, sometimes my customers, they got an isolated sensors in the middle of nowhere, but most of the deployments are massive IoT. And I know what things will be interesting for sensors to satellites, but I can't reconcile how we're ever gonna make money out of that model, and I cannot reconcile how the customer is just not gonna teach me eventually. So that's my opinion so far, because it's critical infrastructure, really keen to pay for your service. I mean, we work in agriculture for a long time, and both Armando and Rob say that agriculture is a big market. I've been there. margins are really, really tiny, and is a brutal market that I think is not ready yet. It's going to be ready in 5 to 10 years, maybe. So, my opinion, having get into pretty high level revenue, that I can't reconcile how simply funneling data without giving extra software can make a satellite constellation profitable. But that's my opinion. Rob, shut it down.
No, of course we differ in our views here, and for me, I think exactly as you said, it's all about costs. So the lower costs we can make it, the simpler we can make it, the easier we can make it for users to integrate with their systems. Fundamentally, we're two opposite ends of the spectrum. You're trying to add and layer as much value as you can in so that your customers can benefit from that. I'm going the other direction. I'm trying to make it as low cost, simple, as basic as it can be, because my bet is that there is a significant amount of users out there that's exactly what they want. They're not even interested in the word satellite or space. They just want an IoT device, and they just want to buy that, and they don't even want to know whether it kind of is going via a satellite or not. It's just got to be put in and work. So if it looks as similar to the other IoT devices that they're deploying and works interoperable with those devices, then that's the bet that I'm placing. Who knows? We'll see. I suspect that there's room for both solutions, and there'll be different things for different people.
Yeah, no, I agree. And I've been there, but I just realized that, God, the amount of things you need to connect when you go in the other side, it's a lot. It's like in the millions to make a revenue. So, but the reality that Satellite IoT is here to provide applications that have never been connected before. So if it's very extreme high value applications that people are very happy to spend a lot of money, or is on the other spectrum, we are making things that no one has ever done. So I think this is the disruption, and it's just amazing.
Yeah, and you're absolutely right. That really and truly, our business model does depend upon an awful lot of connections, because there's low value in each one. So for that reason, there's been an awful lot of effort on our sort of intellectual property development. Yeah. It's been about the receiver side, and it's about how do you handle that without the collisions? How do you adapt and modify the LoRa protocol to ensure that you can handle the density of users that you need in order to close a business model. Of course, I'm convinced that we've done that. We'll see.
And Giovanni or Armando, any thoughts on this?
Well, go Armando.
Please go ahead, Giovanni.
Well, on our side, I would say it doesn't change too much because I believe the kind of demand for both kind of IoT constellation is really to keep our cost down and the value up. So for us, it doesn't change too much which kind of protocols, if it goes through a gateway or not. It works for us. We try to be really agnostic on this side and transparent. So all our network connection interfaces are really transparent to this. We just need, of course, in case to develop a network that is needed for some particular application. But right now, at this stage, I don't see so many deep difference on our side. Of course, it's a lot on customer side, but not on our side.
I think my answer is quite similar. We at the end of the day, we're the infrastructure provider, so we're relatively agnostic as to what the customer is going to use or work on for their network. What we try to do is enable whatever company needs a satellite to operate in the IoT space. We try to enable them to have access to that infrastructure cheaply and quickly and effectively and reliably. So that's what we want to kind of underpin the market for, like provide that reliably. On our side, for the constellation as a service side, well, again, we're relatively agnostic. What we want to do is enable as many players as possible to be able to be connected. So we're relatively neutral here as a company.
Interesting business models, actually. The four of you have completely different models, which I appreciate. I'm going to Well, I have a question for myself, but also I'm going to read out the questions now from the Q&A box. If there are more people asking for questions, please write them there. My question is the following. It's more technical. For each of the satellites, how much data can you actually store? I assume it's a store and forward system. And how many sensors? What does that mean in terms of number of sensors you actually storing on the satellite, and then you're downloading eventually into a gateway? Who's going to answer that?
Rob, you want to go?
Yeah, sure. I mean, it actually is a very common question that we get from from most satellite or people experienced in this field. But actually, the magnitude of data here is minuscule. I mean, typically the messages we're dealing with are sort of 10 bytes. So you did the sums of sort of like a million users, 10 bytes, in comparison to the sort of bandwidths that you see out of traditional higher bandwidth systems. The magnitude, the volume of data is minuscule. It's actually not the design challenge that we face. It is the real design challenge is about collisions and clashes. Okay, makes sense actually. So basically, between two ground stations, basically, you will still be able to upload data until you come to the next station, and then you download it. Basically, it's continuous. I understand. Okay. Even with sort of tens of millions of devices in the field of view, when you reach the next ground station, you've literally probably got 10 seconds or so, and you can get all the data down of a good connection. Okay. So that in a sense leads to an interesting challenge for people like Leaf, because what we're about is the quantity of connections rather than what they're used to, which is selling a full pass, which is what, because we don't need 2 minutes of a pass to get all of our data down. So it's then, how do you optimize that from their point of view? How many customers can you schedule into a single pass in order to recover your CapEx investment in that ground station? Yep. Oh, thank you so much. That's a good answer, and I fully appreciate it. There were a few questions here from people who actually are dealing with frequencies and regulators, which are not there anymore. I think you may have answered them already. But there was one on 800 megahertz. Would there be a future for 800 megahertz? I mean, there is a 1.3, sorry, 130 something. There's 400. There is S-band as well. Now WRC is looking at around 3 gigahertz, as well as 1.4, 1.5, I think, if I'm not mistaken, 1.6 gigahertz. There is also other frequency bands where there is IoT devices actually deployed, let's say around 800 megahertz. Is there something there for the future of satellite, this kind of systems?
I guess it really depends on the solution, because if you look at and Rob, please tell me if I don't exactly know if you guys work on ISM or UHF, but all those sensors to satellites company, more or less, they operate around UHF, and this is due to the form factor of the antennas and the that you need to connect to the sensors. I mean, we operate in S-band, so it's a completely different game. So I think the technology solution really depends. I mean, a Mariota or a Swarm, or they will not be able to operate in S-band. They will not close the link, and so it's really depend on the technology, I guess. I found S-band quite, for us is a bit different, because Rob was saying before that the sensors send bytes. The sensors that we connect send kilobytes. So we kind of go on a little bit of a more extreme, more data, sensors data, and kilobytes a month and stuff like that, more data. Okay, and we also aggregate 1,000 sensors data in one spot. So now we are starting talking about megabytes or gigabytes. So it's a lot of data, and it's an exercise that you can do in S-band. S-band, it's a tricky one, because S-band it's owned by most Iridium and Globostar in one spot, and the rest is mainly EchoStar, really, and Inmarsat and all the big operators. We managed to bring it to use S-band, so now we can operate globally. That's really good. I know an IoT satellite constellation that operates in L-band, that is our friends in Switzerland. And, you know, I would like also to make everyone notice that when I started and when, you know, Rob started and we all started 5 years ago, and IoT satellites was the thing, you know, and we all select a different solution and a different frequency allocation. It's correct that there are always new companies going up and down, you know, in the pitch land, but it's still just the 5 of us, you know, that have put stuff into space, are putting things into space. So that it's hard because it's not just a technology game, it's a frequency game. And now we got good filing, we are quite high in the filing hybrid as well. So I actually don't agree that there are like tens and tens of IoT company coming online in LEO. It's pretty stable. I think the ecosystem is waiting to see who is gonna manage the frequencies, who is gonna bring into use and coordinate them. And there is not that crazy investment that has been Earth observation. It's a bit more conservative, I believe.
Okay, another question I have here is from most likely the first one on the top, actually, a question from a university, most likely. If a technical university would like to participate in service operation testing, is that possible? I guess we'll have your email on the presentations. I guess they are free to contact you directly if they wish to make some kind of a testing with your system, right?
Absolutely.
Okay, so I think that answers the question. Just use the emails which you'll find on the presentations and on the recording once we get the recording up and running on YouTube. Another question from Frederick Menz is the CO2 emission reduction. Will IoT satellite network help in this aspect? Or similar aspect about the ecology and the environment, basically?
I think it just speaks really to me to the general possibilities of IoT. Yeah. I mean, you think of any large challenge like global CO2 emissions, you can imagine, well, if you can get information, then you must be able to actually make a difference there. So if you can get information, more precisely about how traffic moves or where it moves, then in principle you can take actions that help save CO2 emissions. I mean, we're seeing a lot at the moment on sort of carbon monitoring. So anything that's sort of like tracking devices or systems that are actually helping carbon trading by being able to transfer data that says how much somebody is using or whatever, then it facilitates the market, which then helps achieve a bigger objective.
Yeah, basically using the sensors themselves on the ground on the Earth, and then using the constellation to relay data from those sensors basically could be used to monitor and control, the environment basically. I have a question which has been here for a while from Pierre. There were some press reports of Lacuna looking to raise 5.5 million in 2020. How did that proceed?
I'd love to know what the source of the press report is, because if that's the case, I know nothing about it. So really interested to hear. I mean, Lacuna's fully funded for the moment. So yeah, I've actually not even seen that rumor. So yeah, interested where these things come from.
Someone wants to give 5 million to Rob, you're welcome.
Yeah.
All right, I'll move up in the questions one by one. So Flavia and Rob, what are your thoughts about market demands for low latency, less than 5 minutes IoT connectivity? Well, let me add something. I think there's a lot of confusion on latency, and people have different things in their mind about latency. Some people think latency is just the free space path loss, free space path delay. It actually should include also the network delays and the computing delays of the network itself, and that's why it's not the 1 millisecond which some of the 5G systems are offering. It's actually much more than the 100 milliseconds or whatever, basically. So anyway, the question is about your thoughts about market demand for low latency, less than 5 minutes in IoT connectivity.
I mean, in my mind, latency is from a customer point of view, right? Data comes out, data comes in, where the customer sees it, and is the entire end-to-end. Okay, so The customer doesn't care where it happens. So because fleet uses our satellites and Orbcomm at the moment, okay, Orbcomm is complicated for us to utilize. Someone asked me what's the difference, because a fleet, our keys, like our kind of special sources, some remote management to monitor IoT deployments, but we use, till we were gonna get there with our satellites, we use Orbcomm when less than 5 minutes latency is needed. We don't always use Orbcomm though, because less than 5 minutes, there are two situations that I see in industrial IoT. One is emergency information, so someone that click for a safety beep, okay? And the others are control and automation in industry. Okay, control automation industry is when a valve needs to be closed, or there is some problem with, you know, all these automation things. We use edge computing for that. So what it means is that the portal on the ground monitor, for example, a valve or a pipeline, and then understand that the pressure is different and automatically activate control. So between, you know, so there are things to do when the latency is managed less than 5 minutes. It doesn't really per se have to include the satellites, okay? Emergency, one interesting things in an energy market though, in the energy market, the information for, so energy is all regulated by a market exchange data. So everything that happened today in the market, like how much energy is generated, how much energy is used, use actually 5 minutes intervals. So the exchange of, like the stock exchange of energy use 5 minutes intervals. So if you want to monitor and control the energy market, you need to be at 5 minute latency or less. Okay, and you cannot use edge computing. You need to get the data to the cloud because you need to enter into the market. So I show you about threat detection. You know, when there is a digger that goes to a gas pipeline, 5 minutes could be too late. So that digger could hit the pipeline in 5 minutes. So there are some occasions in which it's really good, and edge computing is not enough, you know, because an operator needs to be informed. So this is why it's interesting to push edge computing a lot. And we're very lucky that we use a system that now is called low latency. Doesn't provide us with everything we need for remote management, but it's good enough.
Right, I think we are basically over time. If you have any last minute thoughts, the four of you, in addition to the fact that one of the questions about hybrid networks, you know, terrestrial and satellite, if you are thinking of doing those kind of architectures. But if you have any other thoughts as well before we end the panel session, the webinar, and also if you want to answer any questions directly, do it as well in the meantime. 1 more minute and then we just end, okay?
I think I'll just finish on a positive note. I think the space, crowded as it seems now, is gonna most certainly turn into a staple, an economic staple worldwide. I think we're moving towards a very heavily space-based economy in the coming years, and investment in this sector worldwide has been growing. So I think you know, there's opportunity and there's great technological challenge ahead, but I think we're in a good position to solve it, whether you are providing various services like Rob and Flavia are doing, or whether you're providing the ground segment or you're doing the infrastructure like us.
Yeah, I want to add on what Armando said, that it's quite of a nice moment today, I would say, or for this year. So last year we've been quite, all of our business has been delayed, I would say, with launches, et cetera, et cetera. This year we've seen some good launches end of last year and so on. And the good thing about this kind of panels and that is that with respect to some years ago, right now we are talking about satellites in orbit, operating, delivering services to the customers. And I think this is the kind of good change that we have seen in the last couple of years, where we were much more talking and now we are much more doing. And this is the good thing that will go to the path that Armando said of space sustainability and really economic development.
Thank you, Giovanni, Armando, and Flavia and Rob. We just closing. Any last thoughts?
I just think it's great to kind of see all the buzz around the sector, and that, IoT itself is obviously really, really interesting, but hopefully what we're going to see is more and more applications, more and more new space companies like ours getting going, sort of bringing the benefits of space to solving broader and bigger problems.
Okay, unless Flavia?
And listen, for me, an important thing to consider is that small satellite company and constellation, they have bigger problem towards incumbents to solve. So us working all together is a really critical point, no matter what application, sends the satellites, gateway, that's irrelevant, when you're fighting for a new economy and new ecosystem. And I do agree with that question about satellites versus terrestrial infrastructure, hybrid system. Doesn't really matter. We need to focus on the customers. We need to give the customers the best options, and I think if as new space ecosystem, we focus on our customers and we give them a good experience, there is nothing we cannot do, and working together and collaborate. There is going to be a merge in all these small satellite companies. So we just friends, enemies, friends. We know we will end up all smashing into something eventually. So we just need to push technologies and focus on IP, because that's the good part of the story, I guess.
Excellent, excellent. Okay, thank you so much for coming to the panel. Thanks to the attendees. We reached 171 attendees live, very constant throughout the presentations, excellent outcome of the webinar. Thank you very much, and we hope to see you soon. We'll have another webinar in about 2 weeks' time on the finance and commerciality of the moon. Thank you so much. Hope to see you soon. All the best.
Thank you all.
Good night,
Bye.
and have a nice day, everyone.
Thanks, everyone.
Thanks.